All right, for this third section, we're going to talk about emerging technologies that also help really differentiate Creo as far as the CAD design for today, but also going into the future. So let's go back to our more. And let's talk about generative design, where you look at more than one option and more suggestions of completely different designs. So specifically over here in this deck lifting mechanism, I want to work with this arm piece. Let's open up that assembly. That looks pretty good. So in this case, I want to improve this. I want to make it stronger, lighter, so forth. So let's go ahead and let's start with this particular component. So maybe I need to take some material out. I'm going to apply some loads to do that and try to see what other kind of designs I can come up with for this. So let's go ahead, let's look at, you can see this piece, I've sort of separated out as separate bodies the pieces that have to be there. This is where everything, I have loads being attached on this edge, I have constraints on the various areas down there. So in this case, I'm going to use one of our Creo 9 split surfaces, divided surfaces, to say this is where I'm going to specifically apply a load when I look at the simulation. All right, so let's turn TechEd back on, and I'll show you what we're going to do with these. So specifically, let's go to generative design. So generative design says, let's apply various criteria of material. What kind of material are we going to work with? What kind of shapes do I need to keep? And where am I going to apply some loads and constraints? So in this case, there on that surface that we talked about, this divided surface, I'm going to specifically put a force load on there. And that's where this piece basically has to withstand, because that's what's being pushed on by the rest of the mechanism. And then I'm going to go ahead and say, all right, we've got a couple of different cases, different materials, different manufacturing processes that might work. And the idea is I can run all of those or any one of them and say, give me an improved design. But what if I have a bunch? In this case, here's a design criteria where I'm going to work with a type of material. You can see it's easy to change that for my generative design. Let's go ahead and add that one and say, yep, now let's see what happens if I do this in stainless. And that looks good. So stainless is active. So now I've got a new design. And obviously this could add up really fast. You could do a whole lot of things. So we also have a new capability in working in the cloud. This is our generative design extension that allows you to basically do all these studies, look at different materials, different loading cases, different constraints, different manufacturing processes, but run them all or run a bunch of them and let the system see what possible outcomes are going to happen. So you can see here, it sees we've got a new study, the one I just created with different material. So I'm going to upload that requirement. And now here I have a design set up. You can see all my different cases, different material, different loading, very mixed pieces there. But it's not something I have to run each one. I can say, let's add this new one to the list. It's going to go off, calculate, generate what it can, see what it comes up with, and then the idea is it'll add it to this list. And so you see various plots of various options depending on what processes, what material. I can look at 1, 10, or 100 different cases and see which one really seems to be fitting, which one's going to work the best for me. You can see down there in 12, that's the one we just added, so it's off calculating, so it'll give me an answer here in just a bit. But the idea is rather than me run one, change something, run it again, change it again, here I just say run them all and actually use the power of cloud computing to say here's a bunch of options, here's what happened with each of the cases, so you can look at How do they fit the design criteria? What are their shapes? What are their sizes? All various options here. And then you can start narrowing it down. Say, okay, maybe we know we want to go ahead and use this material, or we want to have a safety factor of a certain amount. You can start narrowing down those various options. So in this case, choose a particular process, a particular set of loads, narrow it down to a couple of others, and then eventually choose the one you like. Right? And that's what it's all about, is having options, having the system suggest possible configurations of parts that might work for you. And at any time you can say, okay, maybe let's take a couple of these and just compare them, sort of narrowing down the criteria. And that's really up to you. And you can do that. You can say, look at these scatter plots. Let's move the area over here because we really want to choose within a given range, things like that. Right? And let the system say, yep, these fit that criteria, these do not. Here's a bunch you might want to look at, and here's all the results from those. So maybe let's go ahead and pick some. So I'll look at the material, look at the stresses, look how it's going to be, choose 1, 2, or 3. Maybe you want to compare some. All of that can be looked at in Generative Design Extension, because this is all working in the cloud, so it can be very, very fast, even with complex cases. But go ahead and narrow it down. See what you like. See what's going to fit your criteria better. All right? So in this case, maybe we choose 3 good results. Let's say this is going where we want, so I'll say, yep, let's put a checkbox in that. And maybe one more, but either way, anytime, there's a couple here, all you have to say is compare it. So now it's going to show, what are the stresses, what are the deformations based on your choices of, process. Is this going to be additive? Is it going to be machined? Is it going to be an extruded part? And what sort of material? What happens if we change from maybe a different type of aluminum or go to stainless steel? Don't want it rusting out there on the mower. All those sort of things. Look at what you want and eventually settle on to at least one, if not more, good possible solutions. If you got one you like, at any point you can say, let's go ahead and save that. All right, so I'm going to take this one on the left. I think that fits all of my criteria. And then I can say, all right, let's use generative. I can go ahead and generate the actual 3D model. So reconstruct it using Freestyle, and the idea is that's automatic. You've got a shape you like, run with it. So I can say go ahead and turn that into a Creo model or add it to the existing one. It's all really up to me. So now I have really customized, got a really good looking part that's going to fit all of my criteria. And that looks pretty good. All right, so I can obviously run the simulation on that. Probably checked it to begin with. Well, now we better make sure we made some changes. What's going to happen here? So I can go ahead and say, let's turn on those load cases and the constraints and run it. So I use live simulation, so it happens right there. See, is this going to be a good part? So I can zoom in. Where's the max stress? I see over on the red, it's going to be over here on the right side. So I can change the max and the min of how I want to look at it. There you go. So the red there, that's the max. Same sort of thing, deformation. How far is this thing going to bend based on these settings? And look at the values. In this case, I can also, of course, animate the deformation. See, this is exaggerated, but really get an understanding of how's this part going to hold up. So it has to be more than just cool looking. It's got to work. All right, so that looks pretty good. Turn that on and off. Now I've got a really good new design, meets all the criteria. Let's go ahead and put it into our assembly. So let's go back. take that part. In this case, just go ahead and replace it. Right, so there's our new one. There we go. That looks great. Okay, so generative design to do AI-powered what ifs. That's really what it's all about. Let's go to the other end of this linkage. Let's use this particular L bracket. And in this case, let's go ahead and use 3D printing as a capability. In this case, we want to remove some material here. This one's got lots of strength, but maybe we want to put some loads on it, put some constraints, and then let's run our simulation and see what we've got. Same sort of thing as always. Where are the hot spots? Where's the max deformation? Where's the greatest stress? Look at that. Let's put it in megapascals. That looks good. And say, show me where those high points are. So, yep, they're going to be right in that area there because that's where we're tugging on it. So that's not too surprising, but good to see and good to know exactly what the numbers are going to be in that area. Do the same sort of thing, deformation. Okay, so maybe this fits, this is good, but what else can we do with it? Well, the answer is you can actually take these results, the stress results, through the whole part and export them, put them into a CSV. And the reason to do that is I can use that to tailor my part design specifically with a lattice, right? So let's go ahead and let's store this CSV model. We'll come back to it just a second. Because what we're going to do is we're going to make this part out of 3D printed part, and I'm going to use that to take advantage of a lattice design. So Creo Additive Manufacturing has some really, really powerful capabilities to do designed-in lattices. And again, that's not something the printer is doing. This is saying, I want to make this a structural part of this piece. So I define basically what do I want that lattice to do. I want to shell out the whole model, or in this case, the whole body for the center section. So let's go ahead and we'll set the size and the type of lattice that we want. So there you can see it regular, it can be rectangular, it can be triangular, it can be more octagonal. Let's set the appropriate sizes. And then say we want to use star shape and so forth. Lots and lots of options. Really amazing capabilities for setting up lattices. And it's one thing, I could have it constant, but in this case, let's use those simulation results. Because what we can do is by bringing in those results, I can vary the density of the part such that it goes from a min to a max and an average, but it's doing it based on those stress analysis, the stress paths that we got from within Creo simulation. Right? So we've set our density. Now let's go ahead and calculate that lattice. And so you'll see, rather than just a flat, constant size, now it's really beefed up the model where it needs to be, and it's thinned it out where it really doesn't need to be. Right? So that center section where we hardly had any stress there, let's put a light lattice. But the areas where it's highest, over there to the right, yep, that's where we need to put a bunch of material. And then, of course, we'll rerun it inside of live simulation to be able to confirm everything. What's the highest stress? What's the highest displacement? See that right there. So really, really rapid creation of very different kinds of parts. Things that you would never think to do just with normal. Let's just put a lattice in. You'll pick a good size, see what works. Let's go ahead and change the density based on, in this case, real stress results from live simulation. Right, so now we check it again, run it through simulation, say, yep, that looks pretty good. Okay, one other good emerging technology is all about augmented reality. So let me go ahead and I'm going to reset this. See, that looks good. But maybe I need to show this to a lot of different people. Well, one way I can do that right inside of Creo here is I'll set up some design states. I have an exploded view, different orientations, different looks at it. So I see that all looks good. Let's save that. But then let's share it. So what I can do is define, first thing, a spatial target. In other words, like a floor of when someone wants to look at this in augmented reality. I can define that and then do a design share and say, let's go ahead and publish this model. So send it up so it's available on a cloud. Basically, anyone who has rights and privileges and access to this model can take a look at it. So terrific for sharing. Even if you're not going to be there, you can send it somebody, a colleague overseas. Various options for quality and so forth. But now I've shared this new design with my new generative design crank and my additive manufacturing crank. And I need to share that. So here you see right from with Creo, I can say, okay, I want to take this and send it to somebody. It can be, public or most likely restricted. Say I want to specifically share it to a certain person or a certain group. In this case, we can even just do it with an email. Say, here's a QR code that will take you all the way there. If they have the augmented reality software, Design Share, they can see it right away. If they don't, it'll download like any other app. But see, basically click on that, point to a floor, in this case a tabletop, and now I can move around. I can look at it in the different configurations that we had set up in the Creo model. Let's go ahead, rotate it around, maybe do the exploded view, show all the different components. But now someone who doesn't have any Creo can really look at my design, bless it, understand it. All the different things you need with the design process can be done with AR Design Share inside of Creo. Right? So that's using Vuforia as a viewer. And now we've got this model set up. Let's do one more function. Let's go back to this first crank. Maybe we're going to do this one as an additive, 3D printed part, and this will be out of metal. So one of the really important things is build direction, we call it. How are you going to position this part on the printer tray to be printed? Because especially with metal, the supports become very important. How many do you have? Because it's expensive material. How can we minimize that? So within additive manufacturing, we have the capability of let's do some analysis. Let's actually look on minimal area, and then let's do an orientation calculation based on certain preferences. I want to minimize downskin area, minimize support volume, whatever your criteria is. But then the system can take a look at the geometry and essentially roll it around, if you will, virtually, and say, here, based on this criteria, here's the best possible orientation for this part. And that can be a really, really useful thing. It might cause you to redesign the part, say, oh, could we tweak this and get a better configuration there? Or in this case, I can also take it into the printer. So you'll see the result of that process. It builds me a coordinate system called build direction. And I can very easily visualize that by preparing it for 3D printing. So within our additive manufacturing for metal printing, I can go ahead and assign a tray and then use that build direction to orient the part automatically. And then I can really understand, say, oh yeah, I see what it's doing. And then I can actually do like producibility studies, have it look for, thin areas, so forth. So really, again, before you go to the 3D printer, make sure this thing's going to work, because you may want to make some changes there. So in this case, do a thin wall check. Looks like we're okay there. No violations of that. So that's good. Well, now let's go ahead and set up some support structures. So we have a full suite of metal support structure capabilities. In this case, let me just rename, and then I'll come in and show you some of the parameters there to activate that one. So all these different things that make up metal supports is what there's types, there's sizes, there's connections, there's holes, lots of different ways. So whatever your preference, whatever your machine likes, go ahead and set up a profile for that. And then right here within the printer tray, let's generate that support structure. All right, takes just a second. Go in and calculate, but the idea is I'll see exactly what it's going to take to print this out, given that criteria. And there is my support structure. Now I can change, let's try, a different type. We want to use a tree structure or a straight structure, whatever is appropriate, and do a lot of what ifs. Say, all right, generate those supports again. So now I'm going to get more of a tree structure to my supports. Have it move away from the part itself and just support areas with sort of a reaching over capability wherever needed. Again, takes just a second, but let's take a look at it. This isn't something we want to have happen out on the machine. We want to really understand it, make changes to the part as needed, and minimize this stuff because it costs a bunch. All right, so now I've got tree structures, and now I've been able to cut down on the amount of material, but still support everything, still using that same capability. All right, so within this tray, I have lots of options for spitting out the file. I can have it go ahead and do the slicing for this particular orientation. Take a look at what each of those looks like. There you see, you've got a little display. Show me the different layers. Really understand how it's going to print, what sort of orientation are the layers going to be. Really help me understand how strong and useful this part is going to be. All right, so now we've looked at all the slices there. And what do we have? 1,400 layers there, based on your particular size. So that looks good. All right. And then from there, I can go ahead and save this tray. Probably the most popular format now, the 3MF format. So that's built into Creo for parts and assembly. I can say, take this, spit it out as a 3MF, and then that file's ready to go to the printer. All right? And that's really Creo, really showing a bunch of emerging technologies, 3D printing, AI-driven generative design, really making new parts, exciting new parts, better parts that's going to last. That's what Creo Parametric is all about.